Problem 13, we have yet another triangle, and we're going to be using the law of sines again. This one's a little bit different because instead of using the law of sines to find an angle, excuse me, we're going to be using the law of sines to find the length of AC. Let's mark AC so that we know exactly what it is that we're going to be trying to find. So, since we've got, let's see, the sine of, we want to use the angle and the side opposite the angle, so we know that the sine of 40 degrees over 8 is equal to the sine of 30 degrees over x. Now you can set that up the other way. If you want to put the trig functions in the denominator, 8 over the sine of 40 equals x over the sine of 30, that's absolutely fine. So we're going to end up with x is equal to 8 times the sine of 30 divided by the sine of 40, which is equal to 6.22, and what's our units? Meters. Please put those units on there. All right, now, the second part of the problem is also very straightforward. We're asked to find the area of a triangle, and you know that when we don't have a right triangle, that oftentimes the best formula to use is that the area of a triangle, put a little triangle right there, is 1/2 AB times the sine of C. That means two sides and the sine of the included angle. So the angle between. So we can use any two sides and any included angle, but now that we found what x is equal to, now I'm going to use the full unrounded amount of this number in my calculation. So we rounded the answer in part B as a kind of like the way we're presenting the problem, we're presenting the answer. I guess that was part A. But when you go back and do a further calculation, please use the unrounded value because you don't want to end up with premature rounding error. So I've got the area of the triangle is equal to 1/2 A is 8, B is 6.22289 times the sine of 110 degrees. So I'm going to round that, and the area of the triangle is 234 meters squared. That's rounded to 3 significant digits.